Thanks everyone for sticking around for last sessions of the day. Really appreciate it. I'm joined by my colleagues today, Chris Crocco from the Splunk team, and the great Steve Moore from Technology Strategy. So I'm Matt Gillies, and today we're going to actually spend some time talking about this concept of digital resilience. And one of the things we want to leave you with today is that we've been talking a lot about digital resilience for security, or digital resilience for the application. And this is really more of a network-centric discussion, where we're actually going to show you some demos on how we make all of this come alive. So with that, I think what's important is let's settle and land on what is digital resilience. We know how dependent that we've all become on our digital infrastructure. So a simple way of explaining this is digital resilience is this ability for a business to continue to operate in the face of any disruption. This could be a cybersecurity attack. This could be application performance issues or network performance issues. Those kinds of things can impact our business itself and also the reputation of the business. And in order to achieve digital resilience, we have to obviously be able to identify the early signs of disruption, look at the actual data, and specifically we're going to show you how we do that for the network. Once we actually have that data, we have those insights, then it's about actually preventing or reducing impact. And lastly, we want to actually look at the end user experience, not just the network performance, or let's say the security performance, but what is actually the end user experience? I think one of the things that we've heard from customers is how do they connect the dots between what's happening with the application and the user down to the supporting infrastructure. Often this has actually required multiple tools, multiple knocks, a lot of finger pointing to actually figure out. So what we're going to show you today is how we actually bring that together in an integrated experience. So how you get started, the path to really digital resilience, it obviously depends on the customer maturity. So often for a lot of customers, it's actually getting that visibility. How do they get visibility into the overall infrastructure? And what we're going to show you today is stuff that's shipping today that allows us to bring data in from the network and provide that visibility. And the important thing here is how we do that with Splunk is not just for the Cisco portfolio, it's actually the data for the entire customer enterprise. This has been a long-standing problem that's been really difficult for customers to achieve. The next is once you have the data, how do you actually prioritize and figure out which events, for example, are the most important events? And how might those events be related to other events that we're seeing? The next is, we can start to look at things like proactive response. Look for patterns in the data. What is this particular event related to this particular application? Or do we see an increase in poor performance, as an example, over a period of time? So now you can actually look at the historical data. And lastly, kind of moving out is how do we optimize the user experience? If we can baseline what normal looks like, then we can actually start to take predictive, proactive recommendations and actually optimize the user experience knowing that we've deviated from normal. So Chris?
Yeah, so let's talk about how Splunk actually does this. And the first thing is data. One of the big differences with the Splunk platform is we can take any data from your environment, structured, unstructured, metrics, events, logs, traces, all of that can go into your Splunk environment, whether that's from your on-prem deployments, your cloud-based services, anything that's emitting data, we will accept it. Once we pull that into the core Splunk platform, we allow you to do a lot of analytics, a lot of insights, and a lot of action against that using schema on the fly, meaning that you index once and you can reuse that data for whatever use case you may have in whatever scenario may be coming up. We have powerful integrations with other tools and within our own portfolio, including the Cisco portfolio, that allow you to visualize that data, apply machine learning and AI, and apply insights across disparate data sets, meaning you can join your business service data with your technical service data and see what's causal and correlative between the two. On top of that is Splunk AI. Splunk has long been in the machine learning and AI ops space, and we're continuing to invest in that with AI assistance and AI insights to allow you to not only understand what's going on in your environment, but have better understanding of how to resolve those problems. And then we're applying these in purpose-built solutions for security and observability so that your teams are able to get to the exact data that they need in the exact format they need to solve the exact problems that they are chartered to solve. So let's talk a little bit about network-specific data. I was just mentioning that we take in all sorts of data, but we're at Cisco Live. This is a networking conference. Let's talk about network data. We can take in all of the different network sources that you may have going on in your environment. So traditional monitoring and alerting data from syslog and SNMP, including polling and traps. We can take in streaming data, including NetFlow and other push-based telemetry coming out of your environment. And if you are getting into cloud-native and microservice environments, we can pull in those high-fidelity metrics from gRPC and eBPF as well. The way that we collect this really depends on which of these data sources that we're talking about. So if you're pulling in syslog, SNMP, NetFlow, et cetera, we have what are called technical add-ons, or TAs you'll hear us refer to them as. And what this is doing is optimizing that data so that your timestamps, your line breaks, all of that sort of stuff looks consistent across that data type so that it's much more optimized for you to interact with once it's in the Splunk platform. If you're dealing with metric data or distributed trace data, very high fidelity, very voluminous data coming out of your environment, we support OpenTelemetry. Not only do we support OpenTelemetry, we're actually the #1 contributors to the open source project. And what this allows us to do is be very agnostic about how we're collecting that metric data, how we're collecting that distributed trace data, and collect it at full fidelity, so no sampling of your metrics or traces. And then if you have a push-based connection, so something like the Meraki API, you can push that directly into your Splunk environment without a collection mechanism, and we'll accept that as well. So collecting all of this data is really good, but what are you going to do with it? Once it's in Splunk, we allow you to do very high fidelity, very granular performance monitoring. So not just watching for things and waiting for them to break, but understanding the overall performance and helping you enhance that experience for your customers. Incident management, so when things do break, we help you find them faster and fix them faster, reducing your MTT everything. And then AI analytics and insights. I just mentioned that we have long been a player in the AI game. We're not just doing AI analytics anymore. We're also giving you AI insights to help you with guided troubleshooting, as well as guided postmortem and root cause analysis, so that you have an understanding of how to prevent this stuff from happening in the future. So I talked a little bit about different collection mechanisms, and a question we get a lot is, which one should I use? And there are really two guiding principles here for the two most common data collection types that we do, OpenTelemetry and technical add-ons. If you're doing high fidelity metrics, distributed tracing, or cloud native services, we recommend that you use OpenTelemetry. OpenTelemetry was purpose-built for these data types. It's optimized for, again, that very, very voluminous metric data that's coming out of your environment, and it gives you what we call the golden signals so that you know exactly what metrics that you're getting, regardless of where they're coming from. If you're pulling from a traditional data source or from a major vendor, not just Cisco, we recommend that you use technical add-ons. So technical add-ons are going to be really good for your things like syslog data, flat file data, SNMP data, where you need to optimize, you need to make sure that everything looks consistent. And the advantage of this is these technical add-ons are often managed by those teams that are producing the technology. So as you'll see in a little bit, we have Meraki, we have Catalyst, we have Thousand Eyes, and those teams are actually building their own technical add-ons for Splunk. And every time that they iterate their own product, they're going to be iterating their TA as well, which makes it easier for you to continue to collect the optimized data. Now, all of those actionability capabilities that I was talking about are going to be in what's called IT Service Intelligence, or ITSI. That's a premium app sitting on the core Splunk platform that allows you to get a lot of insights into your data about your technical services, your business services, how they interact with each other, as well as that optimized incident management experience. So instead of dealing with a laundry list of alerts, you're dealing with optimized episodes that represent a singular condition in your environment. It also allows you to apply that AI ops concept. So we're taking models that are aligned to your data types and applying them to your data and your services such that we're reducing that mean time to detect issues, mean time to respond to issues, and then proactively prevent those issues in the future. So let's talk about a couple of the scenarios that you can do today. The first thing that we've integrated with is ThousandEyes. Now, ThousandEyes has built OpenTelemetry into their agents. It's already available today. And what that allows you to do is anywhere that you have ThousandEyes doing testing for your environment, whether that's on-prem in your data centers, your campus and branch environment, unowned networks like CSPs, you're able to use those agents to push via OpenTelemetry high-fidelity metrics about your environment into Splunk that you can then take and align with your application data, including application synthetics, for a full end-to-end visibility of your environment and the impacts that are taking place.
And this is our enterprise environment for the demo, where we have Meraki and Catalyst, wired and wireless switching, ThousandEyes and Splunk. And by bringing these solutions together and integrating them, and joining their data together, we have the ability to extend our visibility end-to-end into the networks and services that are impacting our application delivery and performance. Now in this case, we're going to look at 3 distinct scenarios, all built around a business application, an employee portal, and show you how with the extended visibility which we've gained, we can build that digital resilience.
All right, so we've told you a lot about ITSI. Let's see it in action. This is what we call a service tree. It's a logical grouping of your business and technical services. So we're aligning the business to the technical services in your environment. What we can see here is our authentication services seem fine, but we have problems going on in our applications and in our network. Network is red. That's the worst thing that we have going on. Let's see what's causing the problem. So if we follow that down into our Meraki service tree, I can see that wireless is where my problem is, and more specifically, my access points. Now, I'm pulling in high-level metrics from Meraki. I don't need everything, but I do need the things that are indicative of a problem. If I go to my failed requests, I can see that there's an individual access point that is my troublemaker. I've now gone from high-level impact to the specific event causing the problem. Now, if I click on that access point's name, we're going to go into what's called the entity view. And these are the metrics about that individual device, that data emitter, that I need to know for its general health. So you can see connection time, current clients, all of the things that you might want to know at a top level about that actual device. The other thing that we can do in here is we have navigation suggestions. So this is telling me that I should probably go into the Meraki dashboard for additional troubleshooting. So let's go ahead and click on that and see what we can find out.
And here is our Meraki dashboard, more specifically, the assurance view. This is where we've gathered all of the health information throughout the Meraki organization, centralized it, analyzed it, and prioritized it. And as you can see here, we have an overall network and an organizational health score that's very high, but we do have some wireless clients that are impacted. More specifically, we can drill down further and see it's authentication related, and we have the identity of the users who are impacted. Now, if we switch into the alerts view, we can not only correlate the who, but the when this issue occurred on the environment, allowing us to correlate with service tickets or other events that could have been happening in the network. And finally, from the wireless health view, we can see that our network health is strong, but it's the network services that were impacted, further confirming that we have an authentication issue, and pointed out here specifically in this case with Radius. We have the who, the how, the what, the where, and the when, and now we can more quickly take action decisively and restore service.
Yeah, so this actually, what we've shown here, this data integration between Meraki and Splunk, this is actually something that we started shipping 3 days ago. So if you go to Splunk Base, which is kind of the app store for these data integrations, you'll find the new Meraki Splunk add-on that actually has the capabilities that we're showing on the left. You could also see some of the things that we're actually actively working on for a little later this year. So all of this data integration that we've shown, this correlation that's actually occurring, and the integration into ITSI, that's actually available today, as of 3 days ago.
Yeah. Exciting stuff. So let's pop back into ITSI for a minute. We know what's going on in our network environment. We know that it's Meraki. Let's take a look at what's going on with our applications. We're pulling in our APM data. We can pull that from App Dynamics. We can also pull it from Splunk APM, which is what we're seeing here. Now, APM's showing us a problem. We've also correlated that with our employee portal. And if we follow that all the way down to our root cause, we can see it's the selections portal within that. And yep, APM and real user monitoring are both showing us a problem. What we can do now is go into what we call an episode, which again is that collection of individual alerts. So rather than going through that laundry list, we have this packaging of ML-assisted modeling that represents the singular condition taking place. Let's acknowledge that and go a layer deeper so that we can actually start solving this problem. So in the episode, we can see that, again, all of the alerts related to the employee portal are collected together. We can see the most impacted services. We have the view of the service tree that's being impacted. And we can go into the individual events and see what my root cause is. I don't need to work all of these alerts. I need to look at the first domino that fell and see if that will cause everything else to self-recover. I can go into those individual alerts and I can see where ITSI is suggesting that I go next. In this case, it's recommending that I go to Splunk Synthetics, which is application synthetics in your environment. So let's go ahead and click on that and see what synthetics are telling us. So we go into the employee portal, and I can look at the last day, the last couple of days, and again, these are application tests taking place. Very similar to Thousand Eyes, but specific to the application. Now, if I look at these tests, I can see that it's TCP problems that are consistently failing. That indicates it might be a network problem. So I go into real user monitoring, I can take a look at my front-end health and my back-end health, and again, I'm seeing my network errors spike. This is less of an application issue at this point, and now I get to point the finger at the network. We're going to pull those Thousand Eyes metrics in, again, using OpenTelemetry into Splunk's observability cloud. And this allows us to look at the exact tests that took place, as well as the exact alerts that came out of Thousand Eyes in the same place that I'm looking at the rest of my application data. From here, I can click into the individual test that popped this detector and go into Thousand Eyes to do further troubleshooting.
And in Thousand Eyes, we have the capability to correlate the impact of the network infrastructure, whether it's your network or a network that you traverse, with the user and application experience. Here, we're using a synthetic test in Thousand Eyes to pinpoint and measure the experience to the employee portal website. And we can see that during a certain window of time, we experience loss and latency, leading to longer page load times. Now, from the Path Insights view at the bottom of the screen, you can see where this impairment was introduced. With the new Traffic Insights, we can correlate the synthetic test measurements with the real flow data of what's traveling through this network device at the moment. We've turned those Thousand Eyes agents into NetFlow collectors, allowing us to make that correlation. We can focus in just on our application traffic or take a step back at a broader view and see that when our throughput to our employee portal went down, other services on the network increased their consumption, leading to the oversubscription and the issues. Now, what will be coming very soon in the Traffic Insights view is the Sankey chart. A quick, easy way to see the proportional impact that a network or a network service contributes to the overall consumption of the environment and the availability.
All right, so we had one more thing happening in our service tree in ITSI. So if we go back through our network, we can see that Catalyst wasn't as degraded, but it is having a service problem. And if I look at my environment, Wired seems to be having the most impact, but I also have access points that may not be causing a wider service problem, but are still having trouble. What this tells me is I have multiple locations within my Catalyst deployment that I need to take a look at. The advantage of this is I have it in Splunk. So instead of swivel chairing between ICE, Catalyst Center, SD-WAN in individual tools, I can now go into my Catalyst app in Splunk and look at all of this in one place. So let's go ahead and do that.
And as Chris mentioned, this is still inside of Splunk, and it's our unified onboarding of all the Cisco enterprise networking data and insights, pulling from Catalyst Center, Catalyst SD-WAN, Identity Services Engine, and very soon to include IoT devices from CyberVision, and further details from ThousandEyes. And in this overview, what we have is all of the security and network alerts that have been brought together and centralized, giving you a quick view of the current issues and exposure in your environment. We've got authentication issues and all the health scores from the network devices and services. Now, in this particular scenario, we have a user who has reported an issue reaching that employee portal website. They can get there with their mobile, but not with their laptop. Let's go explore and see how we can figure out what's going wrong and how we can restore service. We'll start with the devices view, and this is where the endpoint information, all of the endpoints that the network has observed, have been brought together for you so you can quickly see who and what the network is aware of. And we found that our impacted users, mobile and laptop, are both known and seen on the network, and more specifically, they're connected through the same wireless controller. So let's look at the network insights view and see if that might be causing our problem. And here in the network insights view, we have the health scores and attributes of all the network infrastructure devices in the environment. In this case, our wireless controller has a health score of 10, which is perfect, giving us an indication this is not the cause of our problem. Further down, we have listed by type and degree other network events that were noteworthy. Things like BGP state change or access point issues in the environment. Well, it's not here, so let's look at the security insights view and see if that might give us an indication of what's going wrong. Now this view starts with an overall threat matrix and grid of all the different types of security-related issues in the environment, whether it's malware, whether it's IPS events, or other types of threats. You have an idea of what currently you're at risk of in your environment. Now here is our user's laptop, noticed under the drop firewall flows. And it's seen that the policy has quarantined it. So when they brought their laptop in that day from home, it didn't pass the posture check. And now we know what's happening, why they can get there with their mobile, but not with their laptop. We can take the steps to remediate whatever is wrong, to bring it up to the network and environment standards, restore service, and get them back in business. What's important here is that, as Chris mentioned earlier, we brought all this data together once into Splunk. But whether it's the security team, the network team, the application team, they all have the same view, which means that they're all working from the same information. They can work together more efficiently and more quickly to identify, remediate, and restore services.
Yeah, I think, Steve, what we just showed here in the second demo, we actually started shipping that TA for Catalyst Center, for Catalyst SD-WAN, and for ICE last fall. So again, totally real, and I should have pointed this out earlier. Everything we've shown, we actually built out in the lab. So there's no movie magic here. We've actually got this entire thing working, just to kind of prove out this particular use case. And I would say the other really key point here is, to belabor what Steve said, we're ingesting the data once from these different places. Data coming from ICE, data coming from Catalyst Center, but that data is being ingested with context. So we know how it's related to a user or the other services. And that's really the important point, is the context for that data. And this avoids kind of us having to leverage multiple different tools and kind of pivoting between different tools and the finger pointing that has historically gone on. We've tried to actually fix this kind of problem in the past.
The one other thing I want to point out with that was NetFlow data, that was syslog data, and that was REST data, all in one place. So that's not something that you've been able to do in the Cisco portfolio before. You have all of these different data types that are now unified, right? That's the big thing to take away, is it's not just data from different controllers, it's data from different data types that are now optimized in one place.
Great. So yeah, I think what we've shown here is, by looking at kind of how we bring data together for digital resilience, now we can actually achieve what every customer has asked for a long time, is how do we correlate what's happening with the business to the supporting infrastructure. And I would say the second part is really how we can actually measure the user experience. So it's not just about the network and the routers particular, it's actually looking at it from a user experience perspective? What's the page load time from the browser for that user that's actually accessing the application? So there's another level of sophistication and granularity we can do when we actually synthesize and bring all of that data together. So digital resilience, this outcome that we really think is valuable for customers, is achieved only when we bring together all of that data for the network, for security, and for application observability. So with that, I think we finished a little early, but thanks very much for everyone attending. Enjoy the rest of the show.
Thank you, everybody.